512, section 512 from your textbook. Volume of a cylinder. A cylinder is like a circular prism because its cross sections are all identical circles. So that circle at the bottom is just whole like a bunch of circles of the same size just on top of each other. And that way we can work out the volume. And it's similar to the prisms that we looked at in the previous section. Same formula. Because of this, we can also apply the Prism formula, which is the volume equals the area times h. So if we know the area of that circle, we just have to multiply that area by the height to calculate the volume of a cylinder. Now we know for a circle that the area is pi r squared. Okay, that's the same circle there. They're identical circles. So the volume is area times the height. If the area is pi r squared, then that's pi r squared times h, and that's pi r squared h. And there's a summary of it there. Now always be careful that the diagram is showing you the radius, not the diameter. Just pi times that distance squared times the height. Let's look at example 18. Find the volume of this cylinder correct to one decimal place. Okay, the first thing we need to check is that the units are the same. So that says centimeters and that says centimeters. So we're ready to go, and also that that's the radius. So recognize that's the radius and not the diameter. And that's the height. Solution. The volume is pi r squared times h. Right, we got that from our formula. There it is. Volume equals pi r squared h. So it's pi. R is 5. So it's r squared. That's 5 squared times h. And h is 12.5. And with the calculator, we've got that. And the four significant figures, we've got 981.7. Now it's centimeters cubed because we confirmed that they're both centimeters, and volume would be cubed, so it's centimeter cubed. Let's have a look at example 19. Calculate the volume of concrete needed to make this pipe correct to 2 decimal places. Okay, so that's a hole in the middle of this cylinder. Okay, so we can consider it as 2 cylinders. We've got this big one on the outside and a small one on the inside. Now, just like in example 18, the first check is to check the units. So we've got meters, meters, and meters. So we don't need to change those. We can use them as they are. Also recognize that that's the radius of the inner circle. And this one is the radius and not the diameter, right? It's a radius of the outer circle. So from that point there to there is 0.4. Right? From there to there is 0.4, and from there to there is 0.35. So this is the concrete part here. We have to calculate the volume of this concrete, which is that donut-shaped thing all the way down from that height, right? So that height. So the way that we calculate this, the method that we use to calculate this, is you calculate the outer using the radius of the larger one, right? So the outer circle, the bigger one, and then once you calculate the volume of that, then you can subtract the volume of this inner cylinder. It looks like a cylinder on the inside. And then you're left with a pipe because we've just got this part only. And when we get an answer, it's going to be this multiplied by the height. Okay, let's have a look at the solution here. The volume of the concrete, it's this part here, right? The solid color all the way down, is the volume of the big cylinder minus the volume of the small cylinder, which they're calling the hole, right? You can see there's effectively 2 cylinders here. So we know that the volume is pi r squared h. So we've got the volume of the big cylinder, so we need to use the big radius, the larger radius, and that's 0.4. So it's pi times 0.4 squared times the height, which is 1.8, minus the volume of the small cylinder. Now the volume of the small cylinder has a radius of 0.35. So it's pi times 0.35 squared times the same height, because the height of both cylinders is the same. And we get this answer, and they asked for 2 decimal places, so it's 0.21. And we had meters, so that's meters cubed. This is where the fun begins. Exercise 512, volume of a cylinder. Question 1 and question 2, and question 3, 4, and 5. Remember to refer back to the examples, the 2 examples at the beginning of this video.